This is a continuation of phase equilibrium diagrams. I believe this is part 3, and on this I'll just go over quick what the diagram is. It's at 1 atm, and it is for a system that is at constant pressure. We're going to assume there's a piston that can move freely, and it's weightless, so it has no mass, and it causes no friction, so it can move up and down, and the volume in the cylinder can change. Inside of it, it's going to have 1 mole of A, 1 mole of A, and 1 mole of B. Mole of B. So the mole fraction of this in the entire system would be 1 mole of A over 2 moles. So therefore the mole fraction of A is 0.5. So on the diagram we will be looking at the system right here. We also will be looking at the system at around maybe 200 degrees. So about right there, 200 degrees Fahrenheit. At that point, we can see that the system is a vapor and a liquid. Remember, anything below this line is a liquid. That's the saturated liquid. Anything above this line is a vapor. Anything between these two lines in this area, right here, is a vapor and a liquid. That our system is right here. And we want to know what the percent is volume and what percent is liquid. So how we do that is we look at 200 degrees. And remember, this is for a phase equilibrium diagram. So that means no matter where in the system, if you're in the vapor phase or liquid phase, in the system it is 200 degrees. It is isothermal. Isothermal. So there is a liquid and a vapor. So for us, we'll be looking at this total distance. And I'm going to say that this distance is 2 centimeters, and maybe this is 3 centimeters. Now we're going to use the inverse lever rule to know what's actually in there. So for the system, we will use the inverse lever rule, which is basically the total length of this is 5 centimeters. 5 centimeters. And 3 centimeters represents the liquid. So 3/5 of the system is actually a liquid. And also, this area, right, this distance right here is the vapor. So 2/5 is vapor. Vapor. And remember, the closer you are to this line, the more liquid you have in the system, in this cylinder or piston. And over here, the closer you are, more vapor. So this is closer to the saturated liquid line, so it's going to have, of course, more liquid than vapor. Now, the real question is, what is the mole fraction of A in the liquid? And what we do is go straight to the point where the temperature meets the saturated liquid line, and you scroll down. And that is about 0.25 moles. So the liquid, it's 2/3, or 2/5, so 1, 2, 3, 4. So this is the liquid, and this is the vapor. And the liquid has 0.25 moles of A in it. So liquid is 0.25 mole fraction of A. So if we wanted to know the actual moles in it, we would say that. Actually, I'll save that for the end. So we just say the liquid is made up of 2.5. So of the liquid, 2.5 mole fractions of it is of A. And the vapor is the same thing. We just scroll down, and we say that's maybe 0.8. So 0.8 for every 100 moles of maybe vapor, 80 of them are of the component A. So how do we find out the actual moles in liquid inside this cylinder? Well, we know that it's 3/5 liquid. So then there's a total of 2 moles. So it's 3/5 liquid times 2 moles. And that 2 moles is then times 0.25 moles of A over a total of the total moles. So just moles of the system. So these moles cancel out, and we are left with, that's 6 over 5 times 1 over 4. So 6 over 20, 4 over 5, or no, 6 can't go into 20. Oh, that's 3 point something. What did I do wrong here? 3? 6/20ths are, actually, I'll pull out my calculator real quick. Alright, so that is actually just 3 over 10, or 0.3 moles of A are in the liquid. That actually turned out pretty nice. Now, how many moles are in the vapor? Moles of A are in the vapor. So we see that the vapor is 0.8, has a mole fraction of 0.8 of A. So that is 0.8 times the volume, or the fraction, which is vapor, which is 2/5, 2 over 5, times the mole fraction of B, which is, okay, make sure I'm doing this right. Okay, sorry, it's 2/5 times 0.8 moles of A per mole, and the system is made up of 2 moles, so not this mole and this mole cancel out, so we are left with 2 over 5 times 8 over 10 times 2, so we have 2 times 2 is 4, 4 times 8 is 32, and then 5 times 10 is 50, and that's just 16 over 25, and I don't know what decimal that is, so 16 over 25 is 0.46. 64 moles of A.